Hello everyone. Today we are going to discuss the fourth problem of Leetcode Weekly Contest 352, which is sum of imbalance number of all subarrays. So we are given an array ARR, and the imbalance number of this array, let's say B, is defined as follows. So let's say we have two arrays. One, let's say, is B. Okay, do that. Say let's say we have array B, and SB is the sorted value of B. SB is the sort of B. Okay, or you can write B dot sort. So after that, let's say our array is, let's say, 2 3 5 7 and 1. Now after sorting that, let's say our B array is this. Now sorted B will be 1 2 3 5 7, 1 2 3 5 7. So for any array B, the imbalance number is defined as the number of indexes such that the difference between this index and this previous index is greater than 1. So there are two index I can see. One is this index, the third index, and the fourth index. So the imbalance number for this array will be 2. Now what we have to do, we are given an array ARR. We have to find the sum of imbalance number of all its subarrays. Okay, so let's take the first example. Let's take this, and I'll try to explain. So nums is 2314. Now what will be the imbalance number of the first subarray? The first subarray is 2, the imbalance number is 0. The second subarray is 2 3, the imbalance number is again 0. 2 3 1, after sorting it will be 1 2 3, so the imbalance number is 0. 2 3 1 4, after sorting it will become 1 2 3 4. So any two values will have the difference equals to 1, so the answer will be 0 here also. Now again we will start from this 3 in this 0. For 3 1, after sorting it will be 1 3. The difference between 1 and 3 is 2, so the imbalance number here will be 1. For 3 1 4, the imbalance number will be 1 3 4. So there is one index whose imbalance number is 2. Sorry, the difference is 2. After sorting it will become 1 3 4. So for the second index, sorry, the first index, if we use zero based indexing, the difference between these two is 2. So the imbalance number here will be 1 again. Now for the for starting from here, for 1 4, the imbalance number will be 1 because the difference is 3, and for 4 it is 0. So the total imbalance number for all the array is nothing but 3. Okay, 1 plus 1 plus 1, 3. So our answer is 3. So you can check here, our answer is 3. Now here the constants are important, because if the length of the array is 10 to the power 5, we have to solve it in order of n log n or order of n. But here the nums of length is 1000, so the problem is solvable in order of n square or order of n square log n. So I have solved the problem in order of n square log n, but there could be some solution involving some pretty approach involving order of n square, but I have used multiset here. So now I will show you how I have solved the problem, and now comes the solution approach. So what is the solution approach? Now we will iterate over every subarray starting from index I. Okay, so we will iterate for every subarray starting from index I. So let's say 1 2 3 5 7. We start from, let's say, 3. Okay, we start from 3. So we will also maintain for every index I. So let's say we are iterating for every index I to n. Now for every index j equals to I to n. Now here I will be equals to 0 to n. Now for j equals to I to n, what we will do, we will initialize a set here, multi-set. Yes. Now let's say we have one element, let's say a of j, a of j. Now we will insert this element in the multi-set, right? Okay, now our first multi-set will be we are starting from 3, so the multi-set will contain 3, so nothing happens. Now the second element comes. Second element is 5. Now we'll insert 5 in the multi-set. Now our multi-set becomes 3 comma 5. Now when we are inserting the multi-set into the multi-set, we will have the pointer to this element. We will have the pointer of 5. Now we will check what is the previous element of this 5 and what is the next element of this 5. Now the previous element of this 5 is 3, so the difference is greater than 1, so we will take we'll initialize our set here, and we'll initialize another value c equals to 0. Now when we check that the difference is 5 and 3 is 2, we'll increment the value of c here. Okay, now comes another value, let's say 7. So we will insert 7 here, 3 5 7. Again we will have the pointer to 7. We will check what is the previous value of 7 and what is the next value of 7. The next is obviously the end of the set, So we'll only check with this 5 and we'll increment the C again. So the total number of increments of C is 2. So we are adding that to our answer. Okay. I hope you got it. Now there is one more catch here. Let's say we had considering this element 1, 2, 3, 5, 7. Instead of that, we have 1, 2, 3, 5, 4, and 7. Okay. This is one trick here. So let's say we are starting from 3. So initially our set will contain 3. Then again after inserting 5 it will contain 5. Now our value of C is 1. C equals to 1 because 3 and 5 are there. Now when we are getting at 4, 4 is inserted in the middle of 3 and 5. So 4 will be inserted here. Now the previous value of 4 is 3 and the next value of 4 is 5. Both have the in the range of 1. So we will not increment the value of C. But you can check is that previously we have inserted because of the difference between 3 and 5. So we have to delete that from C. So we will check what is the previous element of C, this current element 4, and what is the next element of the current element 5. Okay. So the difference between these two, if it is greater than 1, then we will decrement the value of C by minus 1. Okay. Now let's jump into the code. You will understand it better. So here I am changing the value, the name of the vector to A, and n is the size of the A. Okay. Here I am declaring one multiset, and here is the value of C. Okay. Now we will find the when we are inserting an element into one multiset, we will have the in the return we will get the pointer of that element. Okay. Now pre will be we will initialize the previous and next by s dot n, the end of the array. Now if the current element is not the first element, we will take the set the pre as the previous element of the current pointer. Okay, that's what we are doing here. So let's say our current pointer is at 5. We will check what is the previous pointer of this. So pre will point to this third element. Similarly, if we are at 5, our previous will point to the 3, and next will point to 7. Okay, this is pre and this next. I hope you got it. That's what I have done here in these two lines. Now we'll check if pre is not s dot n, because we will initialize pre with s dot n. If pre is not s dot n and the difference is greater than 1, we are incrementing the value of C. If similarly, if the next is not s dot n and the value is greater than 1, we are incrementing the value of C. Now if both are not the end of the set and the difference between them are already greater than 1, so we have already added them in the difference C. Okay, so we will now decrement them as C minus minus, and at the end for this subarray for I to j, we are our imbalance number will be C. So we'll be adding C to our answer. So the overall time complexity of this algorithm will be order of n square log n. So considering this is 1000, so it will be order of 10 to the power 7, but our complexity is not n square exactly. The time complexity is n into n minus 1 by 2. So n into n plus 1 by 2 exactly. So this will be around 5 into 10 to the power 5 and 10. So the overall time complexity is around order of 5 into 10 to the power 6, which is solvable in both C++ and Python, I think. So I will give the link of this code in the description box. And if you have any doubt in any part of the video, please write in the comment section. Also, please like the video and subscribe to the channel if you find this helpful. Thank you.